What if I told you that a galaxy exploded in fury, releasing so much energy that its flash echoed through the universe for billions of years until it reached our eyes in 2023? It wasn't a supernova. It wasn't a neutron star collision. It was something rarer, more mysterious, a gamma-ray burst coming from a galaxy once considered ordinary. This is the story of 3C216, the galaxy that roared in cosmic silence and left us with more questions than answers. It all started in late 2022. The Fermi-Lat Space Telescope, specialized in detecting gamma rays, the most energetic form of light in the universe, picked up an unusual spike from a seemingly harmless region of the sky. The source? A galaxy called 3C216, nearly 9 billion light-years from Earth. But on May 1st, 2023, this galaxy erupted in activity. On that day, the gamma-ray output from it increased by 176 times. To give you an idea of what that means, if its normal brightness was like a candle, this burst was a giant spotlight aimed straight at us. It was the highest energy spike ever recorded in this galaxy since we started observing it. But why was that so shocking? Because 3C216 is what astronomers call a steep spectrum compact source, or CSS. That usually means a young galaxy with short, underdeveloped matter jets. In theory, these galaxies shouldn't be major gamma-ray producers. They simply don't have the structure to generate such extreme bursts. But 3C216 doesn't seem to follow the rules. It has a relativistic jet, a beam of particles accelerated to near light speed, and that jet is tilted in our direction. That makes it more like a blazar, even though it's not officially classified as one. And that's where things get even more interesting. During the burst, it wasn't just the gamma rays that surged in intensity. Telescopes observing other wavelengths, like Swift, also detected a dramatic increase in X-rays, ultraviolet light, and even visible light. It was a multispectral explosion. The whole body of the galaxy seemed to light up as if it were being fried from the inside. But what could cause a galaxy to do that? The answer lies in a fascinating physical process, synchrotron self-compton, or SSC. Here's how it works. Imagine super-energetic electrons moving within the galaxy's jet. They spiral through magnetic fields, emitting light. That's synchrotron radiation. But then, those same electrons collide with the very photons they just emitted, transferring even more energy to them. The result? The photons become gamma rays. It's a kind of energy cannibalism. The particles are feeding their own explosion of light. Using the simultaneous observations, gamma rays, X-rays, UV, and optical, scientists were able to model this event with precision. They used the JetSet software to simulate the conditions of 3C216's jet during the days of the explosion. The simulation showed the emitting region was probably the size of the solar system, and the particle energy dropped day by day, like embers cooling after a cosmic fire. But there's more. The galaxy seemed to emit light from just one specific zone. That's rare. Usually, such explosions involve multiple regions of the galaxy with complex and hard-to-interpret behaviors. But in the case of 3C216, all signs point to a single blob of super-energetic plasma, a knot in the jet, becoming unstable and exploding with energy, and then slowly fading out. This behavior is a goldmine for those studying active galactic nuclei, the famous AGNs, because it shows that even galaxies that seem calm, young, or insignificant can harbor explosive mechanisms capable of rivaling the most aggressive black holes in the cosmos. And if you think this is just another scientific curiosity, think again. These gamma-ray bursts are so powerful that if they happen near Earth, they could affect our atmosphere, destroy satellites, and even trigger mass extinctions. Luckily, this event happened billions of years ago and very, very far away. But the universe is vast, and there's no guarantee that a similar burst isn't heading our way right now. still traveling through the darkness. Back to 3C216. The burst could only be interpreted thanks to coordinated work from multiple telescopes and spectral analysis across many wavelengths. It was 5 days of intense observation, compared with older data from 2010 and even from the 1960s. The difference in emission levels was staggering. It was as if the galaxy had been silent for decades and suddenly decided to scream. At the end of the event, scientists noticed that the cooling pattern of the particles matched perfectly with what you'd expect from a single-zone event, with progressive energy loss and a shift in the spectral curve. But in the final days, the model no longer fit as well. The explanation? The original emitting zone likely cooled so much that other regions of the galaxy began to dominate the emission, breaking the simplicity of the SSC model. In other words, the burst died, but the chaos kept going. Now stop and think with me. How many galaxies like this are hidden in the sky? How many are about to unleash a similar burst of energy, and we just don't have sensitive enough equipment to catch them? And more. How many of these explosions have already happened but are still traveling through space, about to reach us? 3C216 is not just a galaxy that burst into gamma rays. It's a powerful reminder that the universe is constantly moving, pulsing, screaming, even when everything seems quiet. It's a reminder that our classifications, our categories, our certainties are just human attempts to understand a cosmos that insists on surprising us. If you love diving into mysteries like this, where science and wonder collide, this is your channel. In the next video, we'll explore a neutron star spinning 700 times per second, blasting radiation like a lighthouse of death. Subscribe, turn on notifications, and help me keep revealing the universe's most mind-blowing secrets. Because in space, anything can happen. And when it does, you'll hear it here.